Okay. In this video, we're going to look at the second style of problem of solving exponential equations. So in the second style of problem, what we're going to actually do is we're going to have to take the exponential and we're going to have to rewrite it as a log. What's going to happen is we're not going to be able to change our exponential equation to have the same base. So you can see here in example 2, I've got 2 to the x power equals 7. This is going to be a problem for us because we're not going to be able to write this with the same base. 2 to some power is going to be fractional to equal 7. So we're going to have to use logs. Now, back in a previous section, we learned how to rewrite logs, and I'll just use a previous easy example. We know that 2 to the x equals 2 to the third, so x is going to be a third, but we were showing you how to rewrite this as a log, and so we knew that our log was going to have the same base as the exponent. So this was going to be log base 2 to the 8 equals to x. And so what we figured out was that our exponent was going to be isolated. Now, we also learned a property that basically said that if our base of our log and our unit of our log are the same, then whatever the exponent is, that's basically just going to cancel out and leave us with our exponent. So we can actually use that skill here. So the property that allows us to rewrite from an exponent to a log, so on this rewrite, is the fact that if the log base and the unit are the same, it equals to its exponent. So I can actually change this to log base 2 of 2x equals to log base 2 of 8. And so we know that log base 2 of 2 cancels itself out, leaving just the x, and then we have log 2 base 8 on the log base 2 of 8 on the other side, so x equals log base 2 of 8, which is what we did on the rewrite. So this allows us to skip this step, but that's the reason it works. Okay, and so if you're comfortable rewriting exponents to logs, so we want to rewrite exponents to logs. This is a very important skill that we should have learned in a previous section, and that's going to help us solve this exponential equation. So let's go back and take a look at some of the examples and work a couple problems ourselves. So you can see in this example number 2, we showed you that property, but what we're asking you to do is simply just skip over that and rewrite the exponential equation as a log, and then use your calculator for log base 2 of 7 to come up with a rounded value. And so that would be how we would solve the second style of problem of exponential equations. So let's take a look at sample problem number 2 and 3. Sample problem 2 is a little simpler version, and sample problem 3 requires a few additional steps for you to eventually use the rewrite. So go ahead and pause the video at this time and try sample problem 2 and sample problem 3. Okay, so if we simply just do a rewrite here, I know that my log is going to have the same base as my exponent, so it's going to be log base 4. The exponent, x, is going to move to the other side, so this is going to be 15, and that's going to equal to the exponent of x. And now what I'm going to do is simply ask you to punch that in your calculator and come up with an approximated value. We'll let you know how many decimal points to round to for the test if it's necessary. In this case, 1.95. If you rounded the 5, if you rounded to the nearest tenth, you would probably have 2.0. But 1.95 is okay for at this point in time. So that's a pretty straightforward one. Now let's take a look at sample problem number 3. And you can see here that the first issue is the base that has the exponent 2x minus 3 is not alone yet. So we have to isolate that first. So we're going to subtract 4 from both sides. So I'm now going to have 10 to the x minus 3 is equal to 17. And now I can rewrite that as a log. So I want to keep my base the same. So I have log base 10 of 17 is going to equal to my exponent, which is 2x minus 3. Now, this is a little different because our exponent was not a variable by itself, but an expression. So now I need to use my calculator to get a decimal form of that log. And now I can simply use basic algebra to finish this problem. So 2x is going to equal to 4.23, and then x is going to equal to approximately 2.12. Okay, so those are two examples of the exponents being changed to logs, and you can see how you have to use your calculator to finish some of these problems.